You see the caption from Alter AI， 有看到吗？Even log into the Alter AI, the link I sent to the Line group. Can you see it? Anyone? Does anyone succeed to get into the page Alter AI? Anyway, 没关系，你做。So in the next 50 minutes, we are going to talk about the HSD. I think it's section 8.4. It's about the integration for trigonometric function. And still, let's just review the differentiation for the trigonometric function first. So the derivative for sine x is equal to sine x, and cosine x, when you take the derivative, is equal to minus negative sine x or minus sine x. Can you see a caption? Anyone already get into a page? No. Issues with folks, you should be able to cover owner, we should only add people to channel can. You know it's a link. Copy link. Okay. Let's see. Okay, try again. We click on the link again. You see, we can see this is the AI called the Alter. It can just organize my speech into English. I think that you should be able to translate into Chinese at the same time. But let's hold on to later time. 有吗？有人可以有看到吗？点进去 so you can see my caption, right? Okay, great. So let's review the differentiation for trigonometric function. Okay, because we do know the integral just the reverse of the integration just reverse of differentiation. Okay, then tangent. So it's the second square. Okay, then cotangent. You see minus second square. And the derivative for differential derivative for secant x which will be secant x and tangent x. For cosecant, it's minus cosecant x tangent x. Okay. So from here we can reply. We can reply so the reverse sine, because the integration of sine is equal to cosine. So if I integrate cosine, which will be equal to what? Will be equal to sine x. Okay. And if I integrate sine x, would be, so if I integrate both sides, you will get minus cosine x plus a constant. Okay. Then if I integrate secant square x dx, you will get tangent x plus constant. If I integrate cosecant square x, you will get minus cotangent x plus constant. You integrate secant x tangent x, you will get secant x plus constant. If you integrate cosecant x multiply cotangent x, you will get minus cosecant x plus a constant. Okay, so basically this is the reverse from the differentiation is the just the reverse to the integration. Okay, get the result here. Okay. Let's look at the other one. Okay, let's find the integral. These two integrals. Okay. The first one is the 3x squared sine x to 3 power. Okay, 3x squared and sine x cubed dx. Okay, and let's just use the substitution, integration by substitution. Then u equal to x to the 3 power, then I can imply. So the u equal to 3x squared dx. So this will be equal to what? Sine u du. So the integration of sine will be equal to minus cosine. So minus cosine u plus c, so it'll be minus cosine x to 3 power plus constant. Okay, then let's look at the secant 3x and tangent 3x. Dx. Okay. Still using the integration by substitution. Then u equal to 3x. I can imply the u equal to 3 dx. So this will be equal to secant u tangent u du, and I need to multiply 1/3 to make equal. Okay, because du equal to 3dx imply dx, so dx equal to 1/3 du. Okay. So b equal to 1/3. Second tangent, integration of second tangent equal to second. So second u plus c. So it's equal to 1/3 second 3x plus constant. Okay. Okay, so bear with me. I will try just the other way. So basically, it's just based, plain and simple. It's just the usual technique of integration by substitution. Question so far? Anything? Can you see a caption from the link I sent you? Okay. No, not you, but you. Yes. Translate to Chinese. We want. Let's see. I think you should be able to. You opened it using the Chrome, right? So you should be able to translate it to Chinese at the same time. Right? Let me see. If I can do it here, let me see if I can do it. Okay, anyway. Let's try another example. Don't forget your homework at home. Okay, this function. Okay, I think I will integrate e to the x, and multiply second square x. Second square e to the x. It looks kind of odd, but it should be this. I want to integrate this e to the x power multiplied by second square e to the x dx. So still integration by substitution. Then u equal to e to the x. Okay. So what? So I can apply the u equal to e to the x dx. So it's equal to second square u du. And we do know the integration for second square is tangent. Look up there, second square. So be tangent u plus c. So be tangent e to the x plus a constant. Very simple. Okay, Let's try another example. You need to just have some EMI. As you know, you see, we've been trying to cope with the EMI classes. So you need to just review some vocabulary before coming to class. Okay. I'm not sure how to show the caption. Anyone join this channel, or if you do, let me know. I need to manually add you into the channel. OK， 如果要加的话，可能要过程。你们不是这个整个它同样的，所以你是我们 Microsoft Office 那个啊，才有办法。Anyway, let's try this one. Okay, we need to do, like I said before the blank. Okay, I said, let's try to do it the other way. So we want to have dx as put dx in the outer integral. So be dy, I'm sorry, be dx dy. Okay, we want to dx dy, dx dy. Okay, here, so instead, everything will be the same, but however, so we have dx dy. So y will be from 0 to integrate from 0 to 1. The upper limit is 1. And the inside integral, the inner integral, which will be, if I fix, and I fix y, I fix y here. So, when I fix y, then so x is from 0 to here. When I fix y, and that would be from this x would be equal to 2 minus 2y, 2 minus 2y. So be 0 to 2 minus 2y, okay? Okay, we'll do a similar things here. For the inside, for the inner integral, so because I integrate over x, so y, I will treat y as I treat y as just constant. So I put these two together, 2 minus 2y, okay? So be 2 minus 2y and x, okay? The interval be, so we treat 2 minus 2y as a constant, and minus x would be minus 1/2 x squared, and x from 0 to 2 minus 2y, 2 minus 2y. Okay, so just the yeah. So if I put 0 here, plug in 0, everything is come to 0. Okay, and I put 2 minus 2y, so I will have a 2 minus 2y to square and minus 1/2. 2 minus 2y squared, so be equal to 1/2. 2 minus 2y squared, so be minus 2y plus 1/2 y squared. Okay, so here, so I integrate 0 to 2 minus 2y plus 1/2 y squared dy. So I will have 2y plus minus y squared, 2y minus y squared, plus 1/6 y cubed. And from just plug in the upper limit is 2 and this, oh, I'm sorry, this 0 to 1. Should be y from 0 to 1. 0 to 1, 0 to 1. So here, 0 to 1. It's not correct. This should be, sorry, this should be 4 minus 4. This is correct, sorry. Give me a second. That's 1/2. 4 minus 8y plus 4y squared, okay? So B 2 minus 4y plus 2y squared. Okay, so this should be, here it should be 2y minus 2y squared plus 3/4. No, it's the 2/3 y to the cube. Let's do y squared first. So be 2 minus 2 plus 2/3. And minus 0, so be 2/3. Okay, that's the answer. Okay, I do the same thing, just similar. But instead, I just have a y as the outer integral. Okay. When I say y, you say y. Y. You see a picture down here. So, because y and y. In English, sometimes you can say y. Y. You can say y. Y without H. So he just translates. He takes you like say, I should say Y, and he here Y. I said why? I said why? 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 Anyway. Interesting. Okay, try London. That's fine. You can see the solution details in the textbook. Okay. Okay. Okay, let's try the other one. Let's see this one will be easier. This picture. Okay, we'll find the volume. So solid region bounded by the surface. A surface e to the minus square on planes of z equals 0, y equals 0, y to x, and x equal to 1. Okay. Here the surface will be the roof. And the plane z equals 0, y equals 0, and y equals x equal to 1. H is defined. See, let me try. Let's look at the z equal to 0. Okay. F of x, y equal to e to the minus x squared. And that's the surface function. And look at y z equals 0, y equals 0, and y equals x, and x equal to 1. Let's look at this one. That would be 1. When you look at this one, just look at this one as the base, okay, the roof, not the floor, okay. 我们就看它的底下这个区域啊。Okay, so that would be when z equals 0, imply what? Z equals 0, that would be xy plane. Okay, so it is xy plane. And y equals 0, which would imply the xz plane. Okay, so be this plane, xy plane is x. Sorry, this should be z. So be this plane and this plane. Okay, xz plane is this one, xy plane is this one, and also y equal to x, which would be y equal to x, be y equal to x. That's 1. Well, that's 1. That's 1. Yeah. 1. 1. So this would be x equal to y. And x equal to 1, which will be is plane, and x equal to 1 will be the plane parallel to yz plane when x equal to 1. And x equal to 1 will be the plane parallel 跟这个